Hey there, welcome to Mr. Lehan Teaches You Stuff. This is grade 9 chemistry lesson 12, molecular compounds. So a molecular compound is when you have two nonmetals join, and when they join they don't steal the electrons like ionic compounds do, so they don't create like positive and negative ions. Instead they share the electrons. Oh, that's nice. And they share these electrons for the same reasons that ionic compounds steal them, and that's to fill up their valence shells so they can be like the noble gases over on the far right of the table that have full valence shells. So water is an example of a molecular compound. I'm sure we're all familiar with water, or H2O. Now H2O has two hydrogens, that's the H2, and one oxygen atom. Now the oxygen needs two more electrons to fill its valence shell. So that's oxygen in the middle, and it has 6 electrons in its valence shell, but it needs 8 to have a full valence shell like neon. The hydrogen, they need 1 electron to fill their valence shells, because then they'll have 2, just like helium. So to fill up the valence shells of the hydrogen and the oxygen, what happens is they link up and they share electrons. So the 2 unpaired electrons that oxygen had are now shared with the hydrogen atoms. So the hydrogen now have 2, oxygen now has 8 in its shell, and everybody's happy. Now molecular compounds can be solids, liquids, or gases at room temperature. So it's not really set in stone that they're all solids or they're all liquids or anything like that. They can be a variety of things. And they have relatively low boiling points. So water, for example, has a boiling point of 100 degrees Celsius. If we compare that to an ionic compound like salt, salt has a boiling point of 1,413 degrees Celsius. So water seems relatively low by comparison. And they usually do not conduct electricity well. So things like rubber or plastic that goes around wires, those insulate us from the wires, right? If you touch a wire that's got a rubber coating on it or a plastic coating on it, you don't get electrocuted, and that's because that plastic is a molecular compound that does not conduct electricity well. Combining capacities. The combining capacity of an element refers to how many bonds it can form with other atoms. So how many other atoms can it be linked to? In general, the combining capacity will be the same as the ionic charge that that element can form. So if we're just looking over here at the nonmetals, well, we'll start off with boron. Boron can form 3 bonds. Carbon, although it can't form an ion, will form bonds, and it can form 4 bonds. Nitrogen can form 3, oxygen 2, fluorine 1, and then helium can form none. And that's the same for the whole columns there. So everything under helium will form 0, everything under fluorine will form 1 bond, etc. Now the reason why the whole column will form the same number of bonds is because the combining capacity will be the same as the number of unpaired electrons in the valence shell. So we'll take a look at carbon. So carbon can form 4 bonds here. Here it's bonded to 4 hydrogens. The reason why, if we look at the Bohr diagram for carbon, is that carbon has 4 unpaired electrons in its valence shell. That means it has 4 empty spots where other atoms can join up with the carbon. Okay, when we are naming molecular compounds, we need to add prefixes to the elements so that we know how many are in each compound. And the reason we do this is because they can combine in different combinations. So even if you have the same 2 elements combining, they can combine in different ways and you'll end up with different chemicals. For example, carbon and oxygen. Just CO is carbon monoxide. That's one chemical. But then CO2 is carbon dioxide, a completely different chemical with completely different chemical properties. So when we're naming molecular compounds, just like ionic compounds, we name the 2 elements and then change the end of the second one to "-ide". But unlike ionic compounds, we need to add prefixes to the elements as well. For example, N2O, if that was an ionic compound, it would just be nitrogen oxide. But these are both nonmetals, nitrogen and oxygen. So we know this is a molecular compound. So we need to add prefixes, and it is dinitrogen monoxide. So let's just quickly rattle through the different prefixes that we can put into molecular compound names. Mono means 1, di means 2, tri means 3, tetra means 4. And these 4 here will be the most common ones that you'll run into, but we'll go through the first 10 possible ones just in case you need them. So penta means 5, hexa is 6, hepta is 7, octa is 8, nona is 9, and deca is 10. So those are all the possible prefixes that you can find in molecular compounds. So when we're naming molecular compounds, if there's only one of the first element, then we don't give it a prefix. So there's no mono. For example, CO2 is carbon dioxide. We don't call it monocarbon dioxide. So if there's a name of a molecular compound that just starts off with an element, just like carbon dioxide, we just assume that that means that it's monocarbon dioxide, but we don't write mono. So let's go through a few examples where we name molecular compounds. This first one is just carbon and oxygen, one of each. So it's going to be carbon monoxide. For the second one, we've got 1 carbon and 4 fluorine. The prefix for 4 is tetra. So this one's going to be carbon tetrafluoride. Then we have 2 nitrogen and 4 oxygen. So 2 is di and 4 is tetra. So we end up with dinitrogen tetraoxide. And then our last example here, we have 1 phosphorus and 3 chlorine. And that ends up being phosphorus trichloride. All right, now if we're going the other way, we want to figure out what the chemical formula is. The number of atoms is already provided in the name, so it's pretty straightforward. Just list the element symbols in order and include the necessary subscripts. So for example, dihydrogen dioxide means there's 2 of each, so you put H2O2. So what is the chemical formula for dihydrogen monoxide? Well, the di means there's 2 hydrogen and then there's 1 oxygen. So that's going to be H2O, better known as water. Then we have carbon tetrahydride. So we know there's going to be 1 carbon. Tetra means 4, so there's going to be 4 hydrogen. So we get CH4, also known as methane. Then we have diphosphorus pentoxide. So di means there's 2. Penta means there's 5. So we get P2O5. And then our last example here, we have dinitrogen hexachloride. The di means there's 2, and hexa means there's 6. So we get N2Cl6. All right, so that's it for the grade 9 chemistry unit. I hope you enjoyed watching these videos almost as much as I liked making them.